We're going to talk about determining if a function is linear. Okay? A linear function, see if you guys remember from grade 9. When written on a graph, if I were to show you a graph of something, okay, is yes, just a straight line. Okay? So anytime we get something on a graph that creates this effect, upwards, it could be flatter, going the other way, all of those are linear functions. The reason being is they all form straight lines. Okay? So this is one way to tell if something's linear. If they've given it to you as an equation, okay, f at x, remember we're using this notation, is equal to, I'm going to say 4x minus 2. Okay? In terms of it being linear, we have to look at the variable in the function. If the variable is to what power, it makes it linear. 1. Okay? Now normally we don't write that 1 in. If there's another variable involved, 3x squared, the variable to the highest power, that would not be linear. Okay? Because this x here is to a higher power. So you look to the variable with the highest exponent. So the highest exponent in this equation right here is to the power of 1. And if it's to the power of 1, it is what?
Linear.
That's right. So this is what makes it linear. Okay. Well, let's say we're not given things so easily. Let's say they haven't given us an equation to look at or a graph. Let's say they've given us values. Okay. We have water poured into a tank. Okay. Here's time. It's measured by the minute. So at 0 minutes, how much water is in the tank?
0.
Makes sense, right? No water hasn't started yet. After a minute, we're at, okay, and it's going to go all the way up to 7 minutes, and it eventually fills it with 9.1 liters, okay? Now, to look at this may be difficult. We could plot all those points, but that could take a while. There's a simpler way to do this. A simpler way to do this is to subtract. If we subtract the second term from the first, and we continue that pattern, we're going to look for something that's called the first differences. Okay? So I'm going to take 1.3 and subtract 0. What are we going to get? 1.3. Okay? The next pairing I would use would be 2.6 and what?
1.3.
Use that 1.3 again. So we have 2.6, subtract 1.3, what are we going to get? Okay? And we're going to test this out. We have to make sure this happens all the way through. If it doesn't at certain points, depending how far off they are, it may not create a linear equation. So we try the next one. 3.9, subtract 2.6. We're going to get 1.3.
I just missed that one.
5.2 minus 3.9.
Yeah.
1.3. 6.5, subtract 5.2. 1.3. It's going to be 1.3. And lo and behold, 1.3. So, what we discovered were all of the first differences. And that needs to be all of them, okay? All of these first differences are identical. So if the first differences are identical, they're all the same, that means we have a linear function, right? So that makes this linear. Now, I also want to talk about domain and range quickly. They've given us time. Now, we know that they didn't at 0 pour nothing, and then all of a sudden at that 1 second pour 1.3 in and stop. We know that this is a continuous process. Okay? So, when we're talking about graphing something, time will always be our independent variable. The other thing, no matter what it is, in this case it's volume, will be our dependent. Because there's nothing we have really on Earth that's going to affect time. We're not going to slow or speed up time. Time will always be the independent variable, okay? And an independent variable always goes on the x-axis. The dependent variable will go on the y-axis. So let's talk about the domain of our x. Because this is technically continuous here, we know this is continuous. That means every second between 0 and 1, x exists. But we're not going to write all those values in. We're going to use a different term for the domain. So what do we write?
1 or ER.
Yeah.
1.
The line. Such that, what is the lowest value of x?
0.
Okay. And we technically do r equal to it, so we're going to put less than and equal to x. And x is less than and equal to, what's the highest value? At 7 minutes, this stops. It is continuous. And this tells us that it's continuous. Okay? If I didn't write that in, right, we wouldn't be able to really write this. We'd be writing just the specific values. Same idea happens with the range. The range are all of our y values here. Okay? So our range is also continuous. So YER means that every real number, so Y is the element of all real numbers. So every number in between all of these values, and the restrictions are, what are the lowest value for Y?
0, 0.
Okay.
Y,
And what's the highest value?
9.1.
9.1. So there's our domain in range. They exist between those 2 points. Oh, Friday.